Hi everyone, Mr. Markwick here. Today's video, we're going to be looking at the normal distribution curve, sometimes called the bell curve, which represents symmetrical distribution of data. Now, if you collect enough data, most sets of data will take the form of symmetrical distribution, represented with the normal distribution curve. And from that, we can work out approximate percentages of data that falls between certain values. Now, although the bell curve or the normal distribution curve, it looks very similar for most sets of data, the exact location and shape of it is determined by the mean. Okay, I'm going to highlight that there in a minute. Highlight that there, which is represented by that Greek letter mu. Forgive my pronunciation there. And also the standard deviation, represented by that Greek lowercase letter sigma. So the mean tells us where the middle of our bell curve or normal distribution curve is, and the standard deviation basically tells us how skinny and therefore how tall or how wide and how short our bell curve will be. Okay, so we say that the mean and the standard deviation are the parameters for the distribution. Now, before we go any further, what is standard deviation? Standard deviation, putting it simply, is just a measure of spread. Okay, so standard deviation tells us how consistent or how spread a set of data is. So the lower the standard deviation, the more consistent the data, the less spread there is. The higher the standard deviation, the more spread there is and the less consistent the data. There are other measures of spread that are commonly used, for example, range, which is the difference between the maximum and the minimum value, or the interquartile range, which is the difference between the lower quartile and the upper quartile, Q1 and Q3. But those, both of those are just looking at two values, the maximum and the minimum for the range, and Q1 and Q3 for the interquartile range. So standard deviation is a better measure of spread because it actually takes into consideration every single piece of data. Okay, now we're not going to be working out standard deviation. For the sake of this video, we're going to be given a mean and a standard deviation, and I guess answer the questions from there. Now, actually, there is a bit of information here about how the normal distribution arises. Obviously, when you're looking at a set of data, in this case, the weight of apples in an orchard, there is obviously variation, and those variations come from a number of different factors. Just like if I was to measure the height of all the students in year 12 across the state, again, there's going to be different variations. A number of factors will affect the height of those students. Okay, for example, the genetic factors. So, but overall, if I have enough data, the height would be represented in a normal distribution curve. Okay, same with the weights of apples in an orchard. All right. Now, if we have the mean and the standard deviation from a set of data, we can work out what percentage of data falls between certain values using the 68, 95, and 99.7% rule. Basically, what that says is that 68, if the data is normally distributed, 68% of the data will lie between the mean, take one standard deviation, and the mean plus one standard deviation. So 68% of the data, in fact, let's highlight, so 68% of the data will fall in this range here, okay? In between one standard deviation away from the mean and one standard deviation above the mean. It also says that 95% of the data will fall between two standard deviations below and two standard deviations above. So here we're looking at this range here, anything in those parts of the bell curve. So here's the mean, one standard deviation, two standard deviations below, and two standard deviations above. 95% of the data, approximately, will fall in between two standard deviations below and two standard deviations above, whatever those values are. Okay, usually be given those values. And then 99.7% of the data, let me change my color, will fall between 3 standard deviations below and 3 standard deviations above. So basically 99.7% of the data will be in this section here. There's obviously 0.13 approximately above, 0.13 approximately below those points, 3 standard deviations above and 3 standard deviations below, but approximately 99.7% will lie between those points. Now, obviously this is just an approximation, and then it breaks it up further into, obviously if you look at it here, 34.13% of the data is between 1 standard deviation below and the mean, okay? So you can break it up further like that. So if you use this graph here, you can basically work out approximately what percentage of data falls between certain ranges, given a mean and a standard deviation value. So let's look at an example here where a sample of cans of peaches was taken from a warehouse and the contents of each can was weighed. The sample mean was 486 grams with a standard deviation of 6 grams. So what I'm going to do is I'm actually going to just draw that. So here's scale down the bottom here, just roughly drawn, within the middle value being my mean, so 486 grams here. And then I'm going to do 1 standard deviation above, which would be the mean plus the standard deviation. So 486 plus 6, which will give me 492 grams. And then I'm going to do another step above, which will give me 492 plus 6. I'm adding another standard deviation, which would be 498 grams. And I'm going to do a third standard deviation step above the mean, adding another 6 grams to that second step, which will take me to 504 grams. Then I'm going to do the same going down. So it's going to be the mean, take away 1 standard deviation of 6 grams, which would take me to 480 grams. I'm going to do the same again, take away another standard deviation, which would take me to 474 grams. And again, I'm going to take away another standard deviation, which would take me to 468 grams. So from that, here's my mean, and this is just a rough sketch of this normal distribution curve. Okay, even though it's not asking me to draw it, I think it's useful to draw it sometimes, just so that you can see what's going on. So based on this, you can see that if I'm using this 68, 95, 99.7% rule, what percentage of data falls within certain values, certain weights? The question actually says, state the percentage of cans that weigh between 480 grams and 486 grams. So basically it's asking me what percentage of cans are between 1 standard deviation below the mean and the mean. What percentage of cans lie in that section of the bell curve? Well, it would be, based on this graph here, simply 34.13%. So the answer to A is 34.13%. Okay. The answer to B is a little bit more complicated, although it's not that difficult. What percentage of cans weigh more than 492 grams? Well, 492 grams is here. It's 1 standard deviation above the mean. But then what it's asking is what percentage of cans are above that value. So basically, what percentage of cans that were weighed are above 492, not just in between 492 and 498, anything above. So in that region as well, and past that third standard deviation above the mean. So we're looking at adding the percentages of this, and this section. And again, if I look at the graph from over here, I'm adding 13.59, 2.15, and 0.13%. So the answer to question B, what percentage of cans weigh more than 492 grams? I'm simply adding those 3 values together. So let's write that down as our working out. It would be 13.59 plus 2.15 plus 0.13. Throw that into your calculator. Okay, should get you about 15.4 13.87, I reckon. My memory serves me correct. So 13.59 plus 2.15 plus 0.35, sorry, 0.13, 15.87. So 15.87% of cans weighed, approximately 15.87%, will be more than 492 grams. Okay, so that's how you will be able to work out questions understanding the normal distribution curve, the mean, and the standard deviation values. It gets a little bit trickier if the question said something like this. Now, this will be my next video. But if the question, for example, said, what percentage of cans were more than 490 grams? Now, 490 grams kind of falls in around about here, right? Which doesn't fall exactly on a standard deviation above the mean. So it's a little bit harder for us to determine. We can't simply just use this graph here. You could estimate, but to get a more answer, we are going to be using a graphics calculator or technology to actually solve questions like this. So that'll be my next video, using graphics calculator or using technology to calculate percentages or probabilities of data looking at the normal distribution. All right, so stay tuned for that one, but just a basic introduction here into the normal distribution curve and working out percentages given and standard deviation values.